opportunity to speak with Dr. Doron Myersdorf, CEO at StoreDot. So StoreDot, as I'm sure a lot of our viewers already know, is developing extremely fast charging EV batteries and aims to be mass production ready for 105 cells by 2024. So thank you, Doron, for taking time for this today.
Thank you for having me.
Thank you. So first of all, my first question is, can you help us understand the current status of your battery technology? Where are you in the process of achieving 105 cells?
So the technology is ready. We are actually shipping now what we call the A samples. This is a 30 amp hour cells that are proof of concept, and they can actually deliver the 1000 cycles in a 300 watt hour per kilogram performance. And these are currently in testing with about 15 car makers around the world. So in terms of the technology readiness, we are there. In terms of being integrated into a vehicle, this is a process that takes at least a year to 2 years that we have already started.
Okay. And what have been the major milestones that you've achieved during this process when you started developing until today? And you recently had this demonstration in Lisbon. So what are the major milestones your company has been able to achieve?
So the first one is actually to reach the minimum, or let's say the best performing range, which is the energy density. And our goal with silicon was to be better than graphite. And we are now at 300 watt hour per kilogram. It's about 720 watt hour per liter. And this is considered, I would say, best in class in terms of energy density. So this was milestone number one that we have reached about, I would say, almost 2 years ago. And now the challenge is to hold this energy density steady and keep improving on the fast charging cycle life. Because at the beginning, we only had like 20 to 40 cycles until the battery reached its 80% performance. And that, of course, is not sufficient for the vehicle. The minimum that we received from some of our potential customers is 800 cycles of consecutive extreme fast charging. And this is the big milestone that we've just reached recently, and we've announced, is that we passed the 1000 threshold cycle. So if the vehicle, let's say, can do 300 miles in each charge, then 1000 charge, it's 300,000 miles. It's like 460,000 kilometers. So this is really actually providing already the minimum requirement for the warranty of the vehicle and the performance of extreme fast charging, because our value proposition and the premise of StoreDot is to provide an experience for the driver that is exactly like fueling.
Understood. So when you say experience like fueling, what we generally hear is that even if you're using fast charging, don't use it all the time. It's not good for the battery health. It degrades very fast if you fast charge it all the time. And here you are talking about extreme fast charging. So are you saying these 1000 or 800 cycles, that particular car can always be charged in that way?
Exactly. This is what differentiates StoreDot, because some others are claiming that they can do every now and then some fast charging, say 15 or even 20 minutes, and they say, you know, this is good enough. But this is not the true experience that drivers are looking for. Drivers need to be able to charge on the go, exactly like with fueling, that even every day you can charge in minutes. And this is what we are delivering. This is something that was considered impossible to do with lithium-ion batteries, but with the innovation around the silicon and the electrolyte and the cell design that we've worked over the last decade, basically, we've finally been able to prove that not only it is possible, but it is also already, you know, in production for the samples. So exactly like you said, we are aiming for an experience that every day you can charge your vehicle in minutes, exactly like you would do with the petrol station.
Okay. And what are the specifications or and form factors that you're currently testing with your OEM partners?
So it's easiest to start with the pouch. and
Mm-hmm.
this is what we're currently shipping. We're shipping pouch of 30 amp hour cells. The dimensions are 300 millimeters by 10 millimeters, so it's like a little rectangle that is easier to test. But of course, some let's say the Europeans are more pushing for a prismatic cell. The Americans are actually using pouch, but maybe they would like it a little larger. There's Tesla that is looking at cylindrical. So there are different form factors that we can customize the chemistry to be. But for this phase of the A samples, we are only shipping the pouch cells.
Okay, understood. Can you tell more about what materials or tech innovations are helping you achieve such fast charging?
Yeah, so first and foremost is the replacement of the graphite in the anode, which is the negative side of the battery. We totally replace it with silicon as the only active material.
Okay.
So when we push the ions to be stored during charging, the ions are moving into the active material, which is silicon, as opposed to the graphite. And this silicon is actually nanosilicon, so there's a lot of nanotechnology in the shape and the size of these particles. So they would enable the ions to be diffused faster. But also there is a lot of effort to control the swelling and the shape of these particles, because silicon has a challenge of being amorphic. It's like a balloon that kind of inflates and deflates when you charge and discharge. So controlling that with some organic coating and some materials that are proprietary, this was our major challenge, is how to protect this silicon during the high power charge. And so these are the key materials are first of all in the anode. But then in order for this to work well, we also need a new electrolyte that would react well and move the ions in an efficient fashion into the active material. So the electrolyte is also one of our let's say key innovations and is proprietary. And of course, the entire cell design with the thin layers of the anode and the cathode that enables to reduce the resistance and allow for this extreme fast charging.
Okay, thank you. And the electrolyte that you're using, it's a liquid electrolyte at this stage, right?
Correct. Currently, it's still a liquid electrolyte. This is like the most efficient, especially for fast charging. We do work on what we call the semi-solid solution, but this will be a 2028 mass production, where we will provide the 100 in 3, 100 miles charge in 3 minutes.
Mm-hmm.
And then the holy grail in our roadmap is about a decade from now, might be a full solid state or still be some with some liquid elements. It's 100 in 2, which we believe then the experience is even better than fueling. Like in a couple of minutes, you can be on the road and have sufficient range.
Okay. And for the batteries that you're targeting in 2024, what are the economics for those batteries? What kind of price premium do you expect these cells to have?
So the cost in general is very similar in terms of its structure. We are, let's say, adding some proprietary elements to the electrolyte, like we said, and we process the silicon. Silicon by itself is not expensive. It's actually the second most abundant element on Earth after oxygen, and it's not a problem. The problem is that we need to process it for nanotechnology, and that might add a few percentage point to the cost. But then the benefit that you get is actually extreme fast charging. So for 2024, we are targeting roughly $80 per kilowatt hour cost, and this is will be comparable with graphite, maybe with a slight premium.
Okay, right. And like you also mentioned, you have a lot of partners in the automotive companies, VinFast, Volvo, Ola Electric being one of them. So, can you tell us about what kind of validation have any of you given to your cells yet?
So we are in testing, like I said, with about 15 OEMs, not only our investors. By
Okay.
the way, we also have Daimler as our investor, Volvo, Polestar, VinFast, Ola, but many others. are interested in this technology because it was considered impossible to do. We are, I would say, at the early phases of this validation process. We did get some feedback already that whatever we claimed is actually verified in the labs. But then now that it starts the stress tests in high temperature, low temperature, nail penetration, swelling during storage. All these challenges are still, I'd say, long-term testing, and this is why it will take another couple of years. This is why we say 2024 until we can actually integrate this solution safely into the vehicle.
Okay, but all these tests, like you mentioned, swelling, nail penetration, have these tests been performed at your facility by your team?
Of course. So, first of all, in order to ship cells by air, you need to go what is called UN 38.3. It's a standard of about 30 different safety tests that you need to go through. And if you do not pass, you cannot ship those cells. So
Okay.
these tests we already passed. But some of these tests now relate to the pack itself and not just the cell. And this is where, we might have challenges with heat dissipation because you have many of these cells together. And so the cooling design needs to be aligned with whatever challenges we see in the pack. And this is something that we have not done yet. And it's work that we need to do together with the OEMs.
Right. The pack manufacturing technology as well as the BMS, everything is going to play a role in actually getting the final product out. So, are you going to work on the BMS side, thermal management side of the pack as well? Is that also in your road?
So we are a relatively small startup. We're 120 people. So even though we are global and we have operations, I think it will be difficult for us to kind of own the pack design itself or the BMS. So what we do is we have a team of engineering experts that are actually working side by side with the OEMs to provide guidance and to give some, I would say, consulting advice on how to best use our technology, but we don't take ownership, not on the BMS and not on the pack itself.
Understood. And recently, you said that the solid state batteries are at least a decade away from mass production. So, were you talking about your own roadmap, or was it more like a general statement? Can you expand on that?
It was both.
Okay.
Our roadmap is aligned with our belief that a full solid state solution it has many challenges, and even though we can show in the lab and we are also showing solid state capabilities, the challenges of scaling up these materials and moving them to roll so we can actually have a cost-effective process is very far away. These factories are not being built yet, and all the tens of billions of investments that are going into battery factories these days are going into a traditional coating process.
Hmm.
So this is why I say that even though in the labs you can start showing things, like we are showing as well, there's a huge gap between the ability to show this in the lab and actually have a cost-effective solution that is commercially viable. And this is why I say all these problems together with the fact that in many of the configurations of solid state, you need to apply high pressure in order to enable the charging. And the fact that there is a very high resistance for fast charging and for us, fast charging is critical, and I believe it will become more and more critical for everybody. Then I think solid state solutions will not be in vehicles in the coming decade. They will be in some other smaller applications, maybe in drones, maybe we'll see them in some buses, like we've seen before, that you can charge them slowly overnight. Um, but the premise of having, let's say in 2025, a
Mhm.
solid state battery that is in production and is in reasonable cost, I think is not realistic.
Okay. I think we have just one more question. And any initial plans for production? How are you approaching the manufacturing planning?
That's a good question. So we have our joint venture and also our investor, Eve Energy in China. This is where we are currently producing, but we've also started production in Korea, and we are in, let's say, some ramp up capabilities in Europe as well. So we are going to stagger it very carefully, where the A samples are being produced in China, but once we move to the B samples, depending on who it will be with, we'll finalize additional locations.
And what do you mean by A samples versus B samples?
So A samples is the form factor that we've currently shipped that is not, a customized design. It's a generic design. The B samples will be already by the definition of a particular OEM.
Okay, customized to the requirement.
Exactly.
Okay, understood. I think that's all the questions I had. Thank you so much for taking time and giving into details all the answers. Thank you so much.
Thank you very much.